Some machines are built so large they stop behaving like machines. They become landscape. They become weather. Tonight, 10 of the largest aircraft ever constructed are waiting in stillness, darkness, and decades of quiet history. We begin with the smallest of these giants and climb toward the very largest. The hangar is cold in the way that concrete and steel are always cold, even in summer. Somewhere above, fluorescent lights hum at a pitch too low to notice, unless you stop and listen for it. The air smells faintly of jet fuel and machine oil, a smell that never quite leaves a place like this, no matter how many decades pass. Outside, runway lights blink in a slow, patient rhythm, marking out a stretch of pavement designed to hold something far heavier than any road was ever meant to carry. Hangars made for aircraft, like these, are engineering projects in their own right, with doors tall enough to swallow a 4-story building whole, built only so something larger could rest quietly behind them between flights. In 1903, the first powered aircraft in human history had a wingspan of about 12 meters and flew for exactly 12 seconds before touching back down in the sand at Kitty Hawk. Orville Wright's flight covered roughly the length of a city bus. It was barely enough distance to prove the idea worked at all. And yet, from that one short hop, in just over a century, engineers would eventually build machines with wingspans nearly 10 times that length, machines heavy enough to be measured not in tons, but in hundreds of tons. So machines that could swallow a space shuttle whole or carry pieces of themselves across oceans before ever being fully assembled into a single working aircraft. There is a reason airplanes this size still draw people in, long after the era of supersonic excitement has faded into something closer to memory. It isn't speed. None of tonight's machines are fast. Most were never meant to be. What they share instead is patience, the slow, exact, decades-long discipline of building something at the absolute edge of what physics allows, and then trusting it to leave the ground at all. Aviation doesn't actually agree on a single definition of biggest. Ask an engineer which measurement they mean, and they'll ask you back. Wingspan, the distance between one wingtip and the other. Length, nose to tail. Maximum takeoff weight, and essentially how much fuel and cargo and risk an airframe can survive carrying into the sky. Interior volume, which has almost nothing to do with how a plane looks from the outside, and everything to do with what it can hide inside itself. A few of tonight's aircraft hold more than one of these titles at once. Most hold exactly one, and that turns out to be more than enough. Some of tonight's aircraft carried hundreds of ordinary passengers across oceans for decades. Others never carried a single passenger at all, made instead to move tanks, helicopters, or entire sections of other airplanes from one side of a continent to another. One of them is shaped almost exactly like a whale, designed only to carry pieces of other aircraft between factories. One of them flew exactly once for about 30 seconds, made almost entirely of wood, at a time when the rest of the world had already moved on to metal. One of them has 2 separate fuselages joined by a single wing, a shape that looks more like a child's drawing of an airplane than an actual one, created first to launch rockets and now used to test vehicles that fly faster than 5 times the speed of sound. And one, the largest of them all by almost every measure that matters, was named after a single word in another language. The word means dream. We will meet all 10 of them in order, smallest giant first, largest last. There is no need to rush. Each one took years, sometimes decades, of careful engineering before any of them were trusted to fly. And each one deserves the same patience in return. If you find yourself returning to channels like this one to fall asleep beside large, quiet, complicated things, you are welcome to settle in here. Some nights it's an ocean liner the size of a small town. Some nights it's the slow physics of a beaver dam. Tonight it's the sky. We come back most nights with new chapters of science and engineering, sized for exactly this kind of stillness. For now, picture a hangar door sliding open just wide enough to let in a slice of cold night air, and on the other side of it, waiting patiently in the dark, the first and smallest of our 10 giants. It is shaped like nothing else in the sky. The shape is the first surprise. Where most aircraft narrow in clean lines from nose to tail, this one swells upward behind the cockpit into something closer to a sea creature than a machine. A smooth white hump riding above a regular fuselage, like a passenger that refuses to sit down. People who work around it call it the flying whale. And once you have watched it taxi toward a runway in early morning light, the official name on its paperwork stops mattering. That official name belongs to Airbus, a company that has never built an entire aircraft in one place. Wings come from one country, fuselage sections from another, tail assemblies from a third, and all of those pieces have to physically meet before a single rivet connects them into something that can fly. For decades, Airbus solved this problem with an earlier aircraft simply called the Beluga, itself a converted A300 with the same whale-like bulge. The original Beluga, introduced in 1995, spent decades carrying far stranger things than airplane parts. Over the years, it transported satellites, helicopters loaded whole without being disassembled, and at least one delicate, oversized painting, each cargo requiring its own careful calculation of weight and balance before the flight crew would even consider takeoff. But as newer aircraft demanded larger and heavier components, that first Beluga ran out of room. Airbus considered simply enlarging it rather than starting over, but the older airframe had already been stretched about, as far as engineers were willing to risk. So, Airbus needed something bigger, and built one starting from a completely different airframe, the A330-200, hollowed out and reshaped, carrying roughly 30% more payload than its predecessor ever could. The original Beluga fleet did not retire the moment its replacement arrived. A handful of the older aircraft kept flying alongside the new one for several years, a quiet overlap that let Airbus manage the transition without ever risking a gap in its own production line. The exact kind of disruption the whole Beluga program existed to prevent in the first place. The result is the Beluga XL, and its proportions are almost gentle by the standards of this list. Its wingspan measures 60.3 meters, its length 63.1 meters, its height 18.9 meters. Numbers that would look unremarkable next to most of the aircraft still ahead of us tonight. 2 Rolls-Royce Trent 700 engines push it through the sky, the same engines used on countless ordinary passenger jets. Nothing exotic, nothing built specifically for this one strange shape. It first flew in 2018, entered regular service at the start of 2020, and by the middle of 2024, a full fleet of 6 had been completed. Loading something this large requires more than an ordinary cargo door. The entire nose of the aircraft, including the cockpit floor beneath it, hinges upward like a visor, opening a straight path from the runway directly into the belly of the plane. So, a 60-meter wing section can slide in along rails without ever needing to bend around a corner. Inside, pilots sit noticeably lower than the cargo bay above them, since the entire upper section of the fuselage was given over to cargo volume rather than crew space. A deliberate trade that puts comfort second to the one job the aircraft actually exists to do. What makes the Beluga XL worth including on a list of giants, despite being the smallest aircraft here, is something almost nobody outside the industry expects. Wingspan does not decide everything. Length does not decide everything. Now, what this aircraft actually wins against every other plane on tonight's list is interior volume. Its cargo hold can swallow 2,209 cubic meters of space, more usable room inside than any of the 9 aircraft still to come, including ones twice its size on paper. A wing section 60 meters long, an entire tail assembly, a finished fuselage barrel waiting to be joined to others further down the production line. All of it fits inside that one bulging hump, because the hump was never an accident of design. Every curve of it was drawn specifically around the largest single piece of an airplane that Airbus needed to move. It flies the same handful of short routes again and again, factory to factory, almost never carrying a single human passenger, are almost never seen by anyone outside the aviation world, unless they happen to live near one of the cities it serves. Toulouse, Hamburg, Broughton in North Wales, where Airbus wings are built before travelling onward to be matched with everything else that makes an aircraft whole. It will likely never set a single record that makes international news, never carry a celebrity or a head of state, never appear on the cover of a magazine. It simply makes everything else on tonight's list possible to build in the first place. One wing, one fuselage section, one quiet flight at a time. Across the Atlantic, Boeing was solving almost the exact same problem for almost the exact same reason, and arriving at a shape that looked nothing alike, built not from a clean sheet, but from 4 airplanes that had already spent decades carrying passengers. Boeing's version of the same problem began not as a fresh design, but as a kind of sacrifice. Building an entirely new airframe from scratch would have taken years Boeing did not have, so engineers reached for 4 existing aircraft instead, betting that converting something already proven would be faster than inventing something new. 4 perfectly good 747-400 passenger jets, aircraft that had already spent years carrying paying customers across oceans, were pulled out of service, stripped down to their wings and tails, and rebuilt almost from the cockpit back. What went back together looked less like a passenger jet and more like a python that had swallowed something far too large for its body. The upper fuselage swollen into a continuous bulge running nearly the entire length of the aircraft. And the problem this solved had nothing to do with passengers and everything to do with a single new airplane. Boeing was building at the time the 787 Dreamliner. Unlike most aircraft, the 787 was assembled from large composite sections built by suppliers scattered across the world, fuselage barrels manufactured in Italy, wings shaped in Japan, and all of it needing to reach final assembly lines in Everett, Washington, and later Charleston, South Carolina, before any of it could become a real airplane. Trucking pieces that size across oceans was never going to work. Flying them required something with a cargo hold unlike anything Boeing had built before. The aircraft that resulted carries an official name almost nobody uses, the 747 Large Cargo Freighter, and a nickname almost everybody does. People call it the Dreamlifter, all because its entire purpose is lifting pieces of the Dreamliner from one continent to another. It first flew on September 9th, 2006, entered regular service the following year, and only 4 were ever built, each one converted rather than constructed new, each one carrying a little bit of its old passenger jet life inside a completely transformed shell. Flying an aircraft this oddly shaped requires its own specialized expertise. The 4 Dreamlifters in existence are operated on Boeing's behalf by Atlas Air, a cargo airline whose pilots train specifically on an aircraft unlike anything else in their fleet, one where the usual rules about weight distribution and airflow over the fuselage had to be recalculated almost from scratch because of that oversized hump running along the spine of the plane. Its proportions sit comfortably in the middle of tonight's list. A wingspan of 64.4 meters, a length of 71.68 meters, both noticeably larger than the Beluga XL we just left behind. Loading happens through the tail rather than the nose. The entire rear section of the fuselage swings open sideways on a massive hinge, exposing the full cross-section of the cargo hold, so that finished fuselage barrels, sections far too wide to fit through any ordinary door, can be slid straight in along rails built into the floor. Once loaded, the Dreamlifter can carry up to 150 tons of cargo nearly 5,000 miles in a single flight. Enough to cross the Pacific from a Japanese supplier directly to the American factory waiting on the other side. Its regular routes connect a handful of very specific places, or composite fuselage sections leave a factory in Grottaglie in southern Italy, while wing components travel from manufacturing plants near Nagoya, Japan, both eventually arriving at the same 2 American cities, threading together a supply chain that spans roughly 2/3 of the planet before a single passenger ever boards the finished aircraft. And yet, for all its visible size, the Dreamlifter loses the one record that actually mattered to the aircraft we just left behind. Its cargo hold holds roughly 1,840 cubic meters of space. The smaller-looking Beluga XL holds 2,209. Bigger on the outside does not always mean bigger on the inside. A small, quiet irony that nobody at Boeing or Airbus, particularly, enjoys pointing out about the other company's aircraft. It's all but one that becomes obvious the moment you compare the two side by side on a runway. Both companies know this. Neither one puts it on a brochure. On the ground, the Dreamlifter looks slow even when it is moving quickly, its swollen upper half seeming to lag a half-second behind the rest of the fuselage as it taxis, an optical illusion created entirely by its unusual proportions. In the air, it behaves more conventionally than its shape suggests, cruising at roughly the same altitudes and speeds as the ordinary 747-400 it was built from, the extra bulk adding drag but never quite enough to ground something. This determined to keep flying its strange, repetitive routes between continents. Both of these aircraft exist because of supply chains, a problem invented almost entirely by the modern globalized way of building things. But the next machine on tonight's list comes from a very different era, when the difficulty wasn't moving airplane parts between two countries, but moving anything at all across the emptiest, coldest stretches of one very large one. That country was the Soviet Union, a nation that stretched across 11 time zones and contained entire regions with no roads worth the name. Moving troops, equipment, and supplies into Siberia or the Far East by truck could take weeks, when it was possible at all. By the early 1960s, Soviet military planners had decided the only real solution was an aircraft large enough to carry tanks and heavy machinery directly to wherever they were needed, runway or no runway, road or no road. The Antonov Design Bureau answered with the An-22, an aircraft its own engineers named Antai, after Antaeus, a giant from Greek mythology who drew his strength from staying in constant contact with the earth. In the myth, Antaeus could never be defeated as long as some part of him touched the ground, and was only beaten once an opponent lifted him entirely off the earth. Soviet engineers, intentionally or not, had built an aircraft whose entire mission depended on doing the opposite of what made its namesake invincible. It is a strange name for something built to fly, but also a fitting one. Nothing about the An-22 ever looked like it wanted to leave the ground. Everything about it, the thick fuselage, the high wing, the enormous undercarriage built for landing on dirt and gravel, suggested a machine more comfortable being massive on the surface of the planet than light in the air above it. It first flew on February the 27th, 1965, and at that exact moment it was comfortably the largest aircraft anywhere in the world. Its design was also a genuine first. No one had ever successfully built a wide-body transport aircraft before the An-22, a fuselage wide enough to load vehicles side by side rather than one behind the other. When it appeared publicly for the first time later that year at the Paris Air Show, the reaction from the rest of the aviation world was somewhere between disbelief and alarm. Western observers, who had been tracking Soviet aviation projects for years, through whatever fragments of information they could gather, had reportedly underestimated just how far along the program already was, and the aircraft's sudden public appearance forced a fairly rapid reassessment of what Soviet industry was actually capable of building. Nobody outside the Soviet Union had been building anything close to this scale. And suddenly, here it was, on full display, wingspan stretched out at 64.4 meters across the tarmac. What made the An-22 even stranger to look at than its size alone was its engines. Most large aircraft of that era used jets. The An-22 used 4 enormous turboprops instead, the Kuznetsov NK-12, and each of those 4 engines turned not one propeller but 2, mounted on the same shaft and spinning in opposite directions from each other. Contra-rotating propellers, as the design is properly called, cancel out a kind of twisting force that a single propeller would otherwise put on the airframe. And on the An-22, each pair measured roughly 6.2 meters across, larger than any propeller ever put into production, before or since. 8 enormous propellers in total, so each one taller than a person, standing with arms raised, all of it working together to drag something the size of a small apartment building up into the sky. The contra-rotating propellers were not simply about raw power. By cancelling out each other's rotational torque, they let the An-22 generate enormous thrust at low speed, without the aircraft trying to twist itself sideways on takeoff. a critical advantage for a plane that needed to get airborne from short, rough strips, rather than the long paved runways most large aircraft depend on. The high wing position also kept the engines and propellers well clear of mud, snow, and loose gravel, since the An-22 was never meant to depend on smooth paved runways at all. It was built from the start to land on dirt strips carved out of the Siberian taiga, on frozen rivers, on whatever flat ground happened to be available near wherever the Soviet military or the state airline Aeroflot needed something heavy delivered. Reinforced landing gear, with far more wheels than a typical aircraft this size, spread the weight wide enough not to sink into ground that would have swallowed a normal jet up to its axles. Production continued from the mid-1960s through 1976, and roughly 70 aircraft were eventually built and delivered to both the Soviet Air Force and to Aeroflot, the state airline. The Aeroflot examples were not simple civilian cargo planes in the way the name might suggest. Their officially civilian status gave them freedom to fly into countries and request landing rights that a clearly marked military aircraft never could, while still carrying out missions that were, in practice, almost entirely military in nature. None of this happened by accident, and none of it went unnoticed. Within 2 years of that first flight, Soviet test crews would begin pushing the An-22 toward records that no aircraft of any kind had come close to before, records that would stand for decades afterward. Those records came quickly. In 1967, barely 2 years after its first flight, the An-22 set 14 separate payload-to-altitude records, a series of test flights designed specifically to prove that the aircraft could do more than simply look enormous on a runway. The most demanding of these involved carrying 100 tons of solid metal blocks, roughly the weight of 70 mid-sized cars, to an altitude of nearly 7,850 meters, almost the height of the world's tallest mountains. Each flight had to be independently verified by the Fédération Aéronautique Internationale, the international body that certifies aviation records, which required precise instrumentation and outside observers to confirm both the altitude reached and the exact weight carried. Soviet engineers were not simply claiming these numbers. They were proving them under rules that applied equally to every country attempting similar feats. And for years afterward, no other nation came close to matching them in the heavy cargo category. Across its full operational life, the An-22 went on to set 41 world records in total, an astonishing tally for a single aircraft type, built for hauling cargo rather than chasing speed or altitude for their own sake. What those records translated to in practice was decades of unglamorous, essential work. The An-22 spent most of its life flying into places that barely appeared on maps, delivering drilling equipment, construction machinery, and entire prefabricated buildings to Soviet outposts scattered across Siberia and the Far East, regions where building a proper road or railway would have taken years longer than simply flying the necessary equipment in directly. When earthquakes or floods struck remote parts of the Soviet Union, An-22s were often among the first aircraft dispatched, capable of landing on damaged or improvised airstrips that would have grounded almost anything else in the fleet at the time, and capable of carrying entire field hospitals, or rebuilding crews to locations where the nearest paved runway might be hundreds of kilometers away. But the lessons learned from building and flying, the An-22 fed directly into Antonov's next major project, an aircraft eventually called the An-124, a design that roughly doubled the payload capacity of its predecessor, while solving many of the structural challenges the An-22's engineers had been forced to improvise around. We will meet that aircraft properly later tonight, but it is worth remembering when we do that it would not exist in its eventual form without the An-22 coming first. Within the Soviet Union, the earlier aircraft also became a genuine source of public pride. The kind of achievement state media was eager to celebrate, appearing on postage stamps and in newsreels as proof that Soviet industry could outbuild the rest of the world when it chose to. There is something almost paradoxical about an aircraft this enormous spending most of its working life unnoticed by the wider world. It never carried passengers, the way the An-124 sometimes does. It rarely appeared in Western news coverage, except as an occasional curiosity photographed at an airshow by enthusiasts who recognized just how unusual it truly was, often describing an almost unsettling sense of scale, a machine that seemed to belong to a different category of object entirely, closer to a building that had somehow learned to taxi than anything most people would casually call an airplane. Its real legacy lives in places few people outside Russia have ever heard of: frozen airstrips and remote construction sites, where, for half a century, an aircraft named after a mythological giant kept doing exactly what its name promised, staying connected to the ground even while it flew thousands of kilometers above it. The handful of examples that remained airworthy in recent years had already logged 6 decades of service, longer than almost any other large transport aircraft still flying anywhere in the world. It is, in its own quiet way, a closed chapter of aviation history now, the kind of aircraft very few people will ever see in person again, even though, for a remarkable stretch of the 20th century, it was simply assumed to be the largest thing capable of leaving the ground, propellers and all. While the Soviet Union was solving its own problem of distance and ice and roadless wilderness, on the other side of the world, the United States military was chasing an almost identical goal for an almost identical reason. Both countries understood, in their own ways, that controlling the largest aircraft in the world had become its own form of prestige, separate from whatever practical cargo that aircraft happened to be carrying on any particular day. The Cold War's appetite for moving entire armies by air did not respect borders or ideology. It simply demanded bigger airplanes, built by whichever side could manage it first, and American engineers were about to answer with one of their own. The Cold War's appetite for moving entire armies by air did not respect borders or ideology. It simply demanded bigger airplanes, built by whichever side could manage it first, and American engineers were about to answer with one of their own. In the early 1960s, the United States Air Force launched a competition for an aircraft the military called the CX-HLS, a shorthand for a heavy logistics transport, unlike anything that had flown before. Boeing, Douglas, and Lockheed all submitted detailed proposals built around the same basic requirement: an aircraft capable of carrying outsized military cargo over intercontinental distances and landing on shorter, rougher airstrips than conventional jets required. Douglas was eliminated relatively early in the evaluation, leaving the final decision as a direct contest between Boeing and Lockheed, two very different approaches to solving an almost identical problem. In 1965, the Air Force chose Lockheed's proposal. What happened to the losing design is one of the quieter, stranger footnotes in aviation history. Boeing had poured enormous resources into its own CX-HLS proposal, an aircraft with high wings and a wide fuselage built specifically for cargo. When the contract went to Lockheed instead, Boeing did not simply abandon the work. Engineers reshaped the design, moved the wing from the top of the fuselage to the bottom, reworked the layout for passengers instead of tanks, and turned the loss into something else entirely. That redesigned aircraft became the Boeing 747, the jumbo jet that would go on to define passenger aviation for the rest of the century. We will spend 2 full chapters with it later tonight. For now, it is enough to know that one of the most famous airplanes ever built exists, in part because Lockheed won a contract Boeing had been counting on. Lockheed's winning design became the C-5 Galaxy, and it first flew on June 30th, 1968. Lifting off from Marietta, Georgia, with test pilot Leo Sullivan at the controls. When the aircraft rolled out for public display before that first flight, observers reportedly struggled to find comparisons that made sense. Its fuselage alone could have housed a 6-story building. Its wingspan exceeded the length of a football field. People who had spent entire careers around aircraft, used to feeling unimpressed by size, are said to have simply gone quiet the first time they watched the full machine taxi past under its own power. The dimensions explained why the competition had mattered so much to both companies. The C-5 measures 247.8 feet from nose to tail, with a wingspan of 222.8 feet and a height of roughly 65 feet, tall enough that its tail fin alone would clear most 6-story buildings. Its maximum takeoff weight reaches 840,000 pounds, a figure so far beyond ordinary aviation. Experience at the time that engineers had to develop entirely new landing gear systems simply to spread that weight safely across a runway. The final design used multiple sets of main wheels working together, distributing pressure carefully enough that the C-5 could operate from many of the same runways used by far smaller aircraft, provided the surface itself had been built to handle sustained heavy traffic. The program was not without its difficulties. Development costs ballooned well beyond original estimates, making the C-5 one of the first American military aircraft programs to draw serious public scrutiny over cost overruns, a controversy that nearly derailed the project before a single aircraft reached the Air Force, and that later became a case study taught in military procurement courses for decades afterward. Despite the criticism, nobody seriously disputed that the aircraft, once it was actually flying, did exactly what the Air Force had asked of it. Production continued in 2 distinct phases, with 81 C-5A models delivered between 1969 and 1973, followed by 50 more advanced C-5B models built during the 1980s, bringing total production to 131 aircraft across both versions. What set the C-5 apart from earlier cargo aircraft was not just its size, but the way its entire structure had been built around a single idea: that loading and unloading needed to happen as quickly and directly as possible, with no compromises made for passenger comfort or aerodynamic elegance. Engineers chose the unusually tall T-tail configuration specifically to keep the horizontal stabilizer clear of turbulent air coming off the wide cargo doors during loading, a small decision that mattered enormously once ground crews started working around the aircraft every single day. None of that structural ambition was visible from a distance, where the C-5 simply looked like an unusually large grey airplane settling onto a runway. Up close, the scale became almost impossible to process all at once. A fuselage wide enough to swallow a two-lane road, doors that opened like the jaws of something much larger than any machine had any right to resemble, and a quiet hydraulic hum running through the whole airframe, as systems most passengers never think about, kept the entire structure ready to flex, kneel, and open on command. What the C-5 can actually carry inside that enormous fuselage reads almost like a logistics fantasy. Two complete M1 Abrams main battle tanks, each weighing more than 60 tons on its own, fit side by side in the cargo hold with room to spare. Alternatively, the aircraft can swallow 36 fully loaded cargo pallets, 6 city buses, several helicopters with their rotors still attached, or an entire mobile field hospital broken into its component parts. The kind of flexibility that let military planners treat the aircraft less like a single-purpose vehicle, and more like an airborne extension of whatever base it happened to be supporting that week, for both ends of the aircraft open completely. The nose hinges upward on a massive visor-like doors, while the tail splits open into wide clamshell doors, allowing vehicles to be driven straight through the entire length of the fuselage and out the other side without ever needing to turn around inside the aircraft. Getting heavy vehicles up to cargo hold height presented its own challenge, one the C-5's designers solved with an unusual trick. The aircraft's many-wheeled landing gear can partially retract on command, lowering the entire fuselage closer to the ground in a maneuver crews simply call kneeling. The process takes several minutes to complete, lowering the fuselage gradually enough that ground crews can monitor it and stop immediately if anything appears misaligned. With the aircraft kneeling, ramps from the nose and tail meet the tarmac at a shallow enough angle for tanks and armoured vehicles to drive straight up into the hold under their own power. No cranes, no specialised loading equipment, just the aircraft adjusting its own posture to make the job easier for the crews waiting below. A C-5 typically flies with a crew far larger than most commercial aircraft would ever need, often including pilots, flight engineers, and loadmasters whose entire job is managing the complex process of balancing and securing cargo that can range from a single oversized satellite component to dozens of smaller pallets packed edge to edge throughout the hold. Getting the weight distribution wrong on an aircraft this size is not a minor miscalculation. It can affect how the aircraft handles in the air for the entire length of a flight that might last many hours, across oceans, in weather no smaller cargo plane would attempt. The original C-5A and C-5B models served for decades, but by the early 2000s, age and an increasingly demanding mission profile had begun to show. The Air Force responded with the C-5M Super Galaxy, a thorough modernization program that replaced the engines, upgraded the avionics, and extended the service life of most of the existing fleet, rather than replacing the aircraft outright. Engineers tested the new General Electric engines extensively before certifying them for the full range of missions the Air Force still required, and the new engines alone reduced takeoff distance significantly while increasing how quickly the aircraft could climb immediately after departure. A meaningful safety improvement for a plane so often operating from short or damaged runways. The modernized version can carry roughly 127 tons of cargo over distances exceeding 2,000 nautical miles. Figures that still outperform almost every other military transport aircraft flying today, more than half a century after the type's first flight. Over more than 5 decades of service, the C-5 has flown into nearly every major operation the United States military has responded to, carrying tanks during the Gulf War, delivering supplies across Afghanistan and Iraq, and flying emergency relief equipment to regions devastated by earthquakes and hurricanes around the world. A few aircraft from the 1960s remain in frontline military service today in any form, let alone one still considered indispensable by the branch that operates it. The aircraft's survival says less about nostalgia than about a simple engineering truth, that getting the fundamental shape and capability of a cargo aircraft right the first time can outlast almost any amount of changing technology around it, provided someone keeps investing in the parts that genuinely need updating along the way. Training a flight crew to operate the C-5 properly takes considerably longer than training on most other military transports, partly because of the aircraft's sheer physical scale, and partly because of how many systems, kneeling gear, dual-end cargo doors, an unusually complex hydraulic network simply do not exist on smaller airframes. New pilots often describe an adjustment period spent relearning basic instincts about how much runway the aircraft needs, how slowly it responds to control inputs compared to anything else they have flown, and how differently it behaves once fully loaded compared to flying nearly empty between bases on a routine transit flight. The aircraft that resulted from Boeing's lost contract did rather well for itself anyway, and tonight it is finally its turn. The aircraft that resulted from Boeing's lost contract did rather well for itself anyway, and tonight it is finally its turn. The original 747 came into existence because of a single demanding customer. Pan American Airways, then the largest international carrier in the world, pushed Boeing to build something dramatically larger than anything flying commercially in the late 1960s, as betting that air travel was about to grow far beyond what existing aircraft could handle. The engineering team Boeing assembled to design it, led by an engineer named Joe Sutter, worked under intense schedule pressure, completing the basic design in roughly 28 months, a pace almost unheard of for an aircraft this ambitious. The first 747 entered commercial service in 1970, and within a few years it had completely rewritten what passengers expected long-haul travel to look like. 2 full aisles, a distinctive upper deck hump originally intended for first-class lounges, and enough seats to make flying across an ocean feel less like a luxury and more like public transportation. For nearly 4 decades, Boeing continued refining the design through several major variants, each one slightly longer, slightly more efficient, and slightly more capable than the one before it. The final and most ambitious version of that lineage was the 747-8, unveiled in the late 2000s as Boeing's answer to a changing industry. Rather than designing an entirely new aircraft, engineers borrowed heavily from the 787 Dreamliner program running alongside it, fitting the 747-8 with new wings and new, more fuel-efficient engines derived directly from Dreamliner technology, all wrapped around a fuselage stretched longer than any 747 before it. The new wing included raked wingtips, a subtly swept-back shape, at the very end of each wing that reduces drag during cruise flight without requiring the more complex folding mechanisms some other modern aircraft use to manage long wingspans on the ground. Stretching the fuselage to its new record length meant extending both the forward and aft sections of the aircraft beyond what any earlier 747 variant had attempted. A structural challenge that required reinforcing sections of the airframe that had remained largely unchanged since the original 747 entered service decades earlier. Engineers had to balance that additional length against the aircraft's center of gravity calculations at every stage of loading, since a fuselage this long shifts weight differently than shorter variants ever had to account for. The passenger version, known as the 747-8 Intercontinental, made its first flight on March 20th, 2011, and entered commercial service with Lufthansa a little over a year later, on June 1st, 2012. At 250 feet, 2 inches long, or just over 76 meters, the 747-8 became the longest commercial passenger aircraft ever to fly. To put that length into a more physical sense of scale, Boeing itself once noted that at typical cruising speed, the aircraft covers a distance equal to roughly 3 American football fields every single second. An enormous machine moving with a speed that somehow never quite registers as fast from inside the cabin, where the loudest sound most passengers ever notice is the gentle hiss of air through the ventilation system above their seats. In its typical 3-class configuration, the 747-8 Intercontinental carries around 467 passengers, somewhat fewer than its maximum theoretical capacity, but with a range exceeding 8,000 nautical miles, enough to connect almost any 2 major cities on the planet without needing to stop for fuel along the way. So unlike many of its predecessors, the 747-8 never became a major commercial success in its passenger configuration. Only a relatively small number of airlines, Lufthansa, Korean Air, and Air China, chief among them, ever placed significant orders for the intercontinental version. Part of the challenge was timing as much as design. By the time it entered service, airlines across the world had begun shifting decisively toward twin-engine aircraft like Boeing's own 777 and Airbus's A350, planes that burned noticeably less fuel per passenger while still covering nearly the same routes. A 4-engine aircraft, however refined, was swimming against an industry-wide current that had already started moving in the opposite direction years before the 747-8 ever left the ground. The freighter variant, the 747-8F, found considerably more demand among cargo carriers who valued its unique nose-loading door and enormous capacity over passenger comfort. That single design feature, more than any other, would end up defining the aircraft's second act. Even as commercial orders for the passenger version slowed to a trickle, Boeing kept building 747-8s for cargo customers who had no interest in twin-engine alternatives, valuing instead the unique nose-loading capability that let oversized freight, generators, aircraft engines, even sections of other airplanes folded into pieces, slide directly into the hold without complicated repositioning. Few other aircraft on tonight's list, or in commercial service anywhere, could match that particular trick. A hinged nose large enough to swallow cargo lengthwise, rather than forcing it through a side door built for boxes and suitcases. A 4-engine aircraft, however refined, was swimming against an industry-wide current that had already started moving in the opposite direction years before the 747-8 ever left the ground. And yet, the story of the 747 as a whole never quite ended the way that current might have suggested. Throughout its long production run, the aircraft earned a nickname that stuck across every airline and every generation of traveller who flew on one, the Queen of the Skies, a title earned partly through scale and partly through sheer cultural presence. For decades, a 747 silhouette was simply what people pictured when they imagined international air travel, appearing in films, in airport branding, and in the memory of anyone who grew up watching jumbo jets climb into the sky from a window seat. Even pilots who trained on dozens of other aircraft types throughout their careers often described checking out on the 747 as a distinct milestone, a sign that they had reached the upper tier of commercial aviation. Production of the aircraft, across every variant going back to that first 1969 prototype, continued for 54 consecutive years, an extraordinarily long run for any aircraft program, civilian or military. By the time the very last 747 rolled out of Boeing's factory in Everett, Washington, in December 2022, a total of 1,574 individual aircraft had been built. That final airplane, a 747-8 freighter, was delivered to the cargo airline Atlas Air in early 2023, and closing out a production run that had begun back when the first moon landing was still months away. Boeing employees marked the occasion quietly, aware that they were watching the end of something that had fundamentally shaped what commercial aviation looked like for half a century. The aircraft itself was a fitting final example, its revenue payload capacity reaching over 130 tons, enough cargo space to carry more than 10,000 solid gold bars, had anyone actually needed to move that much gold by air on a single flight. What made the 747 era remarkable was not just the aircraft's size, but what its existence made possible for ordinary people. Before the jumbo jet, intercontinental air travel remained largely the province of the wealthy. The increased capacity the 747 introduced helped drive ticket prices down across the entire industry, turning long-haul travel into something millions of families could eventually afford, rather than something reserved for a fortunate few. An entire generation grew up associating the experience of a long flight with that particular silhouette out the terminal window, the raised cockpit, the gentle hump behind it, long before anyone needed to know the model number to recognize what they were looking at, the same way a particular kind of car or train comes to represent an entire decade in memory. The 747-8 has not disappeared from the skies, despite the end of new production. Freighter versions continue flying cargo routes for companies like Atlas Air, UPS, and Cargolux, their distinctive nose-loading doors making them especially valuable for oversized freight that simply will not fit through a conventional cargo door. Today, spotting one in passenger configuration has become a small event in itself among aviation enthusiasts, since the number of carriers still operating them in that role continues to shrink every year as airlines complete their own transitions toward twin-engine fleets. A handful of 747-8s also serve in VIP and government transport roles around the world, carrying heads of state and senior officials who require an aircraft with both the range and the presence that only a 4-engine jumbo can still provide. Perhaps the most symbolically significant of these roles, is still ahead. The United States government selected a pair of 747-8s to become the next generation of Air Force One, designated the VC-25B, with entry into presidential service expected before the end of this decade. Converting a commercial airframe into a functioning Air Force One involves far more than repainting the exterior. It requires extensive modifications for secure communications, self-defense systems, and the kind of structural hardening expected of an aircraft meant to serve as a mobile command center during a national emergency, a process that has taken considerably longer than originally planned, a reminder that turning any aircraft, however capable, into the most scrutinized airplane in the world is rarely a simple engineering task. There is something quietly satisfying about an aircraft built specifically to outlast its own moment, retiring from mass production only to keep flying in exactly the roles that matter most, freight that nothing else can carry, and passengers important enough that only the largest, longest aircraft in commercial service will do. Few aircraft manage that particular kind of second life, fading from the spotlight without ever quite leaving the sky entirely, content to keep doing useful, unglamorous work long after the headlines have moved on to something newer. If the 747 spent half a century defining what a jumbo jet should be, the next aircraft on tonight's list was built specifically to take that title away from it by going one step further in almost every dimension that could be measured. Boeing's 747 had always been recognizable by its hump, the partial upper deck that gave the aircraft its distinctive silhouette, but never extended past roughly a third of the fuselage's total length. Well, Airbus looked at that design and asked a simple question. What if the upper deck ran the entire length of the aircraft instead of stopping partway through? The answer became the A380, the only aircraft ever built with two full-length passenger decks from nose to tail. Where the 747's upper level had always felt like an exclusive add-on, a small lounge perched above the main cabin, the A380's second floor is simply another complete floor of the airplane, as long and as wide as the deck beneath it. The aircraft measures 79.8 meters across the wings, 72.7 meters from nose to tail, and stands 24.1 meters tall, dimensions that make it, by almost every measure that matters for a passenger aircraft, the largest one ever built. Final assembly took place in Toulouse, France, the same city where so many other Airbus aircraft come together, with pieces arriving from factories across Europe in much the same way. The Beluga and Beluga XL we met earlier tonight were built specifically to transport them, a quiet reminder of how connected every aircraft on this list ultimately is to every other one. Numbers like these are difficult to hold in the mind without some kind of physical comparison, so Airbus has offered a few over the years, almost as a kind of party trick. The wings alone are wide enough that 70 ordinary cars could be parked wingtip to wingtip across that single span. The combined floor area of both passenger decks adds up to roughly 550 square meters, the equivalent of 3 full tennis courts, laid side by side inside a single aircraft. And the total interior volume across all 3 levels, the 2 passenger decks and the cargo hold beneath them, so comes to around 1,570 cubic meters, enough empty space, in theory, to hold 35 million ping-pong balls. Power comes from 4 engines, available from 2 different manufacturers depending on which version an airline ordered, either the Rolls-Royce Trent 900 or the Engine Alliance GP7200, a joint venture between General Electric and Pratt & Whitney. Both options were designed specifically to meet the unusual demands of lifting an aircraft this heavy off relatively ordinary runway lengths, while still meeting increasingly strict noise regulations at major international airports. An aircraft this large could not simply appear at existing airports without some accommodation. Many of the airports the A380 was designed to serve had to widen taxiways, reinforce certain sections of pavement, and build entirely new double-deck boarding bridges capable of loading passengers onto both decks simultaneously. Infrastructure investments that quietly limited how widely the aircraft could ever be deployed, regardless of how many an airline might have wanted to buy. None of these numbers fully capture what it actually feels like to stand underneath one on the ground, looking up at a wing the size of a small park, but they come closer than most engineering specifications usually manage. Airbus built the A380 to feel less like boarding an airplane and more like entering a building that happened to be capable of flight, an impression the company leaned into deliberately, eventually offering airlines the option to install onboard lounges, bars, and even private shower suites on the upper deck. Passengers who have flown on it frequently mention how quiet the cabin feels compared to other wide-body aircraft, an effect created partly by the engines being mounted further from the fuselage than on most aircraft, and partly by the sheer mass of the airframe itself, which dampens vibration in a way smaller, lighter aircraft simply cannot replicate. The aircraft seats a maximum of 853 passengers in an all-economy configuration, though almost no airline ever actually flies it that way. Most configure their A380s for somewhere between 400 and 600 passengers spread across multiple classes, trading maximum capacity for comfort and space. And for a while, simply owning one became its own kind of statement among the airlines fortunate enough to operate them. Our few aircraft in commercial history have generated as much genuine spectacle simply by existing on a runway. Long lines of curious onlookers gathering at airports around the world, just to watch one push back from a gate or climb slowly into the sky on an otherwise ordinary scheduled flight. For something this large, that climb itself looks almost unnaturally gentle, a building-sized object rising at an angle that seems too shallow to make sense, until it simply does, and disappears into the clouds like anything else that flies. That image, a building-sized aircraft disappearing gently into the clouds on an otherwise ordinary flight, was almost exactly what passengers at Changi Airport witnessed on October 25th, 2007, the day the A380 carried its first paying passengers into commercial service. Miss Singapore Airlines flew that inaugural route from Singapore to Sydney, and seats on board were auctioned off for charity beforehand, some going for tens of thousands of dollars, simply for the privilege of being among the first people ever to fly on the largest passenger jet in history. The aircraft itself had first flown 2.5 years earlier, lifting off from Toulouse on April the 27th, 2005, after a prototype unveiling in January of that same year drew aviation journalists from around the world to watch something this size roll out of a hangar for the first time. Regulators spent more than a year afterward testing and certifying the design before any airline could legally carry a paying passenger on board. A thorough process both the European and American aviation authorities only completed in late 2006, and examining everything from evacuation procedures to how the aircraft behaved on a single engine before granting their approval. For a while, the A380 looked simply unstoppable. Airlines wanted the prestige of operating it. Passengers requested it by name when booking long-haul routes. And production climbed steadily until it peaked at 30 aircraft a year in 2012 and again in 2014. But underneath that visible success, the math was quietly working against the program. Engine manufacturers were developing new twin-engine technology that let smaller aircraft fly nearly as far while burning far less fuel. And one by one, the airlines that had once queued up for the A380 began directing their orders elsewhere instead. Calling the program a failure, as some commentators eventually did, never quite captured what actually happened. An Airbus set out to build the largest passenger aircraft anyone had ever attempted, succeeded completely at the engineering challenge, and simply discovered too late that the industry itself was moving towards smaller, more flexible aircraft rather than larger ones. The A380 never struggled to do what it was designed to do. It struggled only because fewer airlines, in the end, needed an aircraft quite that capable of moving quite that many people on quite so few routes, a problem of timing and market shape rather than one of engineering at all. The end came in February 2019, when Emirates, the program's largest and most loyal customer, reduced its outstanding order from 162 aircraft down to 123. Without enough remaining orders to justify keeping the production line running, so Airbus announced that deliveries would stop entirely once the existing backlog was completed. The very last A380 ever built rolled off the line in Hamburg in December 2021. And on its final test flight before delivery, the pilots are said to have traced the shape of a heart in the sky at 35,000 feet. A small, quiet goodbye to an aircraft that had defined an entire era of long-haul travel. That aircraft, the 251st and last of its kind, was delivered to Emirates on December 16th, 2021, bringing that single airline's fleet to 123 of the type, by far the largest A380 operator in the world. Production ending did not mean the aircraft disappeared entirely from the world's busiest airports. After a difficult stretch during the pandemic, when most A380Hs sat grounded for months at a time, demand for the aircraft recovered faster than many analysts expected. Passengers, it turned out, genuinely missed flying on it. The extra space, the quieter cabin, the sense of occasion that came with boarding something this large. By the middle of the 2020s, more than a dozen airlines around the world were still operating the type regularly on their busiest, most prestigious long-haul routes, often the only aircraft in their fleet capable of moving enough passengers at once to make certain routes profitable in the first place. There is a particular irony in an aircraft built to dominate an industry, instead becoming a kind of beloved exception within it, too expensive and too specialized to ever be ordinary again, but too well loved by the people who fly on it to simply vanish from the skies either. Frequent flyers began tracking which routes still use the type the way some people once tracked rare birds, planning connections specifically around the chance to fly on one again. Airlines that brought their grounded A380s back into service after the pandemic often found passengers actively seeking out flights on the type, treating a booking confirmation that mentioned the aircraft model as a small piece of good news in itself, worth planning a trip around. While Airbus and Boeing spent decades competing over enormous passenger jets built for paying customers, a very different kind of giant was being built on the other side of the world, one with an entirely different purpose in mind from the very beginning. That other giant was built far from Toulouse, Hamburg, or Everett. Inside design bureaus, most Western aviation enthusiasts of the era could not have named, even if asked, and it never carried a single paying passenger across its entire operational life. Design work on this aircraft began in 1971, inside the same Antonov bureau that had built the An-22 we left behind several chapters ago, under a project name that revealed nothing about its purpose. Izdelia 400, simply product number 400. The Soviet military still needed something even larger than the An-22 could manage. An aircraft capable of carrying the kind of oversized military equipment that no existing transport, Soviet or American, could lift at all. Assembly of the first airframe began in 1979, and after 3 years of construction, the aircraft that would become known as the An-124 made its maiden flight on December the 24th, 1982, lifting off from a factory aerodrome in the Sviatoshin district outside Kiev. NATO intelligence analysts, tracking the program from a distance the way they had tracked the An-22 nearly 2 decades earlier, gave it the reporting name Condor. Inside the Soviet Union, it carried a different name entirely, Ruslan, borrowed from a heroic figure in Russian folklore, known for both his strength and his loyalty. It would turn out to be the last aircraft personally overseen by Oleg Antonov himself, the founder of the design bureau that bore his name, who died in 1984, only 2 years after watching his final design leave the ground for the first time. The An-124 introduced engineering solutions that went well beyond simply scaling up the An-22's basic formula. Rather than one continuous cargo hold, the fuselage used a genuine double-deck configuration, with the upper and lower sections pressurized separately from each other, a design choice that reduced overall structural weight while actually improving safety margins for the crew in the event of an emergency landing. The lower deck handled the cargo itself, while the upper deck housed the crew rest area and a small compartment for additional personnel, a separation that meant a problem with cargo pressurization, leaking fuel vapor or shifting loads, never had to threaten the people flying the aircraft. Both ends of the aircraft could open at once, the nose lifting on hinges while the tail split apart into clamshell doors, letting vehicles and equipment drive straight through the entire length of the hold without needing to turn around inside it. At the same basic trick Lockheed's engineers had landed on independently for the C-5 Galaxy on the other side of the world. Specifications alone explained why Western observers took the aircraft so seriously the moment they finally saw it in person. The An-124 measures roughly 69 meters from nose to tail, with a wingspan stretching 73.3 meters and a maximum takeoff weight in the neighborhood of 405,000 kilograms once fully loaded. Its payload capacity reaches 150 tons, enough to carry locomotives, generators, entire sections of bridges, or other aircraft folded down into transportable pieces. The aircraft made its first public appearance in the Western world at the 1985 Paris Air Show, 3 years after that initial test flight outside Kiev, and by then, rumours about its existence had already been circulating through aviation intelligence circles for some time. 4 enormous turbofan engines power the An-124, each one a D-18T model built by the Ivchenko Progress Design Bureau and manufactured at the Motor Sich plant in Ukraine, the same engine family that would later power the even larger aircraft we will meet near the very end of tonight's list. Beneath those engines, the landing gear carried forward a lesson learned directly from the An-22. Multiple sets of wheels, 24 in total across the main gear, designed to spread the aircraft's enormous weight widely enough to operate from unpaved or lightly prepared airstrips when a proper runway simply was not available. Production of the An-124 split across 2 separate factories, one in Kyiv and another in Ulyanovsk in western Russia, an arrangement that made perfect sense while both cities belonged to the same Soviet state, and became considerably more complicated once that state dissolved entirely a few years later. For a brief window in the early 1980s, building the largest production aircraft in the world simply meant deciding which of 2 sister factories would assemble. Which particular airframe, a logistical question nobody at the time imagined would eventually become a geopolitical one, entirely outside the control of the engineers who actually built the thing. What made the An-124 different from the Cold War giants that came before it was not simply its size, but how seamlessly its later career would cross the line between military necessity and ordinary commercial usefulness. Does transition that neither the An-22 nor the C-5 Galaxy ever quite managed in the same way. That crossover from pure military necessity to genuine civilian usefulness became official on December 30th, 1992, when Antonov secured civil certification for the aircraft, just over a year after the Soviet Union itself had ceased to exist. A transition neither the An-22 nor the C-5 Galaxy, the 2 giants we spent earlier chapters with tonight, had ever quite managed to make in the same deliberate way. Almost overnight, an aircraft built specifically for Soviet military logistics found itself available, at least in principle, for hire by absolutely anyone willing to pay the asking price for it. A sudden and almost surreal shift for a design team that had spent the entire previous decade answering only to the state and its strictly military requirements. 2 companies emerged to handle that commercial demand: Volga-Dnieper Airlines in Russia and Antonov Airlines in Ukraine, both flying examples of the same aircraft for entirely civilian charter work. Their business model was refreshingly simple and remarkably durable over the following decades. If a piece of cargo existed that was too large, too heavy, or too oddly shaped for any ordinary freighter to carry, someone, somewhere, would eventually call one of these 2 airlines. Over the following decades, An-124s carried satellites destined for orbit, complete electrical generators for power plants under construction, entire railway locomotives, so disaster relief supplies after earthquakes, and at the height of the COVID-19 pandemic, urgently needed medical equipment flown between countries that suddenly had no other way to move it fast enough. Space agencies, including NASA on more than one documented occasion, chartered the type specifically because nothing else in their own fleets could match its particular combination of payload, reach, and proven reliability. This kind of charter work occupies a strange, narrow corner of the global aviation industry that most ordinary travelers never think about at all. There is no fixed schedule, no regular route map, no predictable booking pattern at all. A flight gets arranged only once a piece of cargo exists that genuinely cannot travel any other way, by ship, by truck, by rail, or by any smaller aircraft. Planning one of these flights often involves engineers calculating precise weight distribution for an object that has never been flown before. Customs paperwork covering countries the cargo will only ever pass briefly over, and a flight crew trained specifically for loads that behave nothing like the standardized pallets most cargo aircraft are designed around. Insurance alone for some of these flights can run into the millions of dollars, since a single cargo item might be worth considerably more than the aircraft carrying it. The aircraft had already proven its long-range capability well before any of that commercial work began. In May 1987, an An-124 flew 10,881 nautical miles without stopping to refuel, a flight that lasted 25 hours and 30 minutes and departed at a takeoff weight of roughly 455,000 kilograms, numbers that, so at the time, simply did not belong in the same sentence as any other cargo aircraft flying anywhere in the world. That single flight, planned almost entirely to generate exactly this kind of international attention, did more to convince skeptical Western buyers of the aircraft's seriousness than any airshow appearance ever could have managed on its own. By the time production wound down in the early 2000s, Antonov and its partner factories had built a grand total of 57 examples of the An-124, a relatively small number for an aircraft this commercially successful, simply because each one took so long to construct, and because demand, however strong, never quite justified opening a true mass production line, the way Boeing or Airbus might have for a passenger jet. A handful of unfinished Soviet-era airframes were completed years later, the very last one rolling out in 2004, more than a decade after the country that had originally designed it had stopped existing entirely. Today, with its larger sibling destroyed in the early days of war, the An-124 now holds a title it never expected to hold this early in its career, the largest military transport aircraft still actively in service anywhere on Earth. Russian operators continue flying their examples for military logistics, while the surviving commercial fleet, grounded by sanctions in some regions and rerouted around new restrictions in others, has had to navigate a geopolitical landscape that none of its original Soviet designers could possibly have anticipated back when the project was still just a number on a drafting table in 1971. While these aircraft moved cargo across the modern world, one charter flight at a time, at the next aircraft on tonight's list never carried cargo at all in the conventional sense. It barely managed to carry itself, just once, for less than a minute. And that single short flight would be more than enough to secure its place in aviation history forever. Its story begins not with an engineer's ambition, but with a wartime emergency, the specific kind that made an entire nation reconsider what it was willing to build out of sheer desperation alone. This particular machine never carried cargo in the conventional sense, and it would carry passengers only once in its entire existence, for less than a minute. Yet, that single short flight would be more than enough to secure its place in aviation history forever, remembered long after the engineers who built it had passed away. By 1942, German submarines were sinking Allied cargo ships in the Atlantic Ocean faster than American shipyards could possibly replace them, threatening to cut off the flow of troops and supplies to Europe entirely. Some months saw losses so severe that military planners genuinely worried the entire war effort in Europe could collapse simply from a lack of ships willing or able to cross the ocean safely, regardless of how many new vessels American shipyards managed to launch. Henry Kaiser, an industrialist already famous for building cargo ships at a pace nobody thought possible at the time, proposed an unusual solution. If U-boats could only attack ships on the water, why not simply fly the cargo over their heads instead, beyond the reach of any submarine entirely, no matter how many of them patrolled beneath the surface? Kaiser lacked the necessary aviation expertise to design such an aircraft himself, so he approached Howard Hughes, the wealthy and famously eccentric aviator and filmmaker, and together the two men pitched the United States government on building a fleet of enormous flying transports, capable of carrying troops and equipment clear across the Atlantic, without ever touching the dangerous water below. The government approved funding for 3 prototypes, under the designation H-4 Hercules. But almost immediately, the project ran into a material problem nobody had fully anticipated. Aluminum, the obvious choice for an aircraft this size, was rationed strictly for military fighters and bombers, leaving Hughes and his engineers no practical way to build their giant transport out of metal at all. Instead, they turned to wood, specifically a laminated birch material developed under a proprietary process called Duramold, in which thin layers of birch veneer were glued together under heat and pressure into a material nearly as strong as aluminum, but built from a resource America had no shortage of at any point during the entire war. 8 enormous Pratt & Whitney radial engines, among the largest piston aircraft engines ever built, were mounted along a wing that stretched roughly 320 feet from tip to tip, a span that would remain the largest of any aircraft in the world for more than 70 years afterward, long after the man who built it and almost everyone who worked on it had died. That wooden construction is the entire reason the aircraft eventually picked up its famous nickname, the Spruce Goose, even though the name is almost completely inaccurate. The aircraft was built overwhelmingly from birch, not spruce, and Hughes himself reportedly despised the nickname, considering it both an insult to the engineering involved and a factually lazy description of what his team had actually built. Some of the birch veneer sheets used in construction were manufactured far from Hughes's California operation, in a mill in Marshfield, Wisconsin, where much of the skilled lamination work was carried out by women, since so many of the men who might otherwise have done that job were already serving overseas in the war. The aircraft was being built to help win, an entire supply chain of careful, patient handwork, quietly running in the background of a war. Most of those workers would never see firsthand. Of the 3 prototypes originally funded by the federal government, only one would ever actually be completed. By the time the war that justified the entire project had actually ended, the H-4 was still nowhere near finished, and a growing chorus of politicians in Washington had begun asking, increasingly loudly, whether the enormous sums already spent on it had been worth anything at all. With aluminum no longer rationed and the original wartime emergency officially over, the government quietly cancelled the remaining 2 prototypes, leaving Hughes with exactly 1 aircraft, an enormous unfinished question mark that the entire country had effectively paid for, and that nobody, including Hughes himself, had yet actually seen fly under its own power. Congress scheduled hearings specifically to investigate the program, and Hughes, never a man comfortable testifying under oath about his own decisions, or found himself facing senators eager to make an example of what looked, from the outside, like one of the most expensive unfinished projects the federal government had ever funded, a wooden aircraft that had cost a fortune and, so far, had never once left the ground. Hughes, never a man comfortable testifying under oath about his own decisions or his own spending, found himself facing a Senate committee eager to make an example of what looked, from the outside, like one of the most expensive unfinished projects the federal government had ever funded. Newspapers covered the hearings closely, often framing Hughes less as a serious aircraft builder and more as an eccentric millionaire who had talked his way into spending the public's money on an oversized hobby, a narrative Hughes found particularly difficult to sit through quietly. So rather than simply answer questions from Washington, Hughes decided to settle the matter the only way he genuinely trusted, by proving the aircraft could actually fly in person, with himself personally at the controls, in front of journalists who had largely arrived that day expecting to watch him fail. On November 2nd, 1947, the H-4 Hercules slowly taxied out onto the calm water of Long Beach Harbor in California, with Hughes himself in the cockpit, alongside a small crew and a handful of journalists and engineers watching from nearby boats. Officially, the plan called for nothing more than a high-speed taxi test, a routine, unremarkable check of the aircraft's handling on the water, before any actual flight attempt would even be considered. Hughes had other ideas. As the aircraft picked up speed across the harbour, he pulled back firmly on the controls and lifted the enormous wooden flying boat into the air, climbing to roughly 25 feet above the water and holding it there for about half a mile before settling gently back down onto the surface. The entire flight lasting somewhere around 30 seconds, from the moment the hull lifted clear of the water to the moment it touched back down again. Witnesses on the surrounding boats reportedly fell silent for a moment before erupting into applause, unsure whether they had just watched a stunt, a vindication, or simply an extremely expensive and well-timed coincidence that happened to occur in front of exactly the right audience. That brief flight, less time than it takes to read this entire paragraph aloud at a normal pace, became one of the most famous 30 seconds in American aviation history. It proved exactly what Hughes needed it to prove, that an aircraft this large, built almost entirely from laminated wood, could genuinely leave the ground under its own power and remain stable while doing so. It also, somewhat anticlimactically, marked the end of the aircraft's flying career rather than the beginning of one. The H-4 never flew again. Hughes kept it in a specially built, climate-controlled hangar in Long Beach for the remainder of his life, employing a dedicated maintenance crew to preserve it in flying condition despite never actually flying it again. A peculiar and quietly expensive form of devotion to a machine that had already done everything it was ever going to do in a single afternoon decades earlier. Engineers who worked on that maintenance crew sometimes spent entire careers caring for an aircraft they knew, with complete certainty, would never again leave the ground under its own power. For decades afterward, the H-4's 320-foot wingspan remained the largest of any aircraft ever built, a record that outlasted the entire Cold War, the rise and fall of the Soviet. An-22 and An-124 we met earlier tonight, and the introduction of jet airliners that would have seemed like science fiction to the engineers who built the H-4 by hand out of birch veneer. Generations of aviation engineers grew up, built entire careers, and retired without ever once seeing that particular number beaten by anything else with wings. A strange kind of permanence for a record set by an aircraft that itself flew for barely half a minute. Today, the aircraft that once carried the weight of a congressional investigation on its wooden wings sits permanently on display at the Evergreen Aviation and Space Museum in McMinnville, Oregon, where visitors can walk beneath the same enormous wing that once held the record for longest in the world, built from a tree species nobody actually associates with its famous, slightly inaccurate nickname. The museum building itself had to be constructed around the aircraft's dimensions, rather than the other way around, since no existing structure in the region could simply absorb something this large through a standard set of doors. And even now, photographs rarely manage to convey just how much space the wing alone occupies inside that purpose-built hangar. That record finally fell to an aircraft built for an entirely different purpose, in an entirely different century, by a company founded by a man who had made his fortune not in shipbuilding or oil, but in software, and who would not live quite long enough to watch his own creation take to the sky. The man behind that new record had made his fortune nowhere near shipbuilding, aluminum, or aviation at all. Paul Allen, who co-founded Microsoft alongside Bill Gates back in the 1970s, spent much of his later life and a considerable share of his personal wealth funding ambitious aerospace, sports, and conservation projects that more conventional, risk-averse investors tended to avoid entirely. In 2011, he founded a company called Stratolaunch Systems, with a specific, almost audacious goal in mind: building an aircraft so large that it could carry a rocket up to high altitude and release it mid-air, letting that rocket ignite its engines already partway to space, rather than fighting through the thickest, most resistant part of the atmosphere from a standing start on the ground below. Achieving that goal meant designing something that looked unlike almost any aircraft that had ever flown before it. Rather than building one fuselage, Allen's engineers built two complete fuselages side by side, connected by a single enormous wing stretched between them, with the cockpit and flight crew located in only one of the two separate hulls. 6 engines, salvaged from retired Boeing 747 airliners, rather than built entirely new, were mounted across that wing to provide enough combined thrust to lift both fuselages, the connecting wing, and whatever oversized payload happened to be slung beneath the very center of the aircraft on any given mission. Reusing existing 747 engines, rather than developing new ones, saved the company enormous sums during development. A pragmatic choice that fit a project already pushing the limits of what private aerospace funding could realistically sustain. The basic logic behind air-launching rockets is older than Stratolaunch itself, and considerably simpler than the enormous aircraft eventually built to do it. A rocket launched from the ground has to fight through the thickest, most resistant layers of the atmosphere using fuel that could otherwise go toward reaching orbit. Release that same rocket from an aircraft already cruising at high altitude, and it skips the slowest, most expensive part of the journey entirely, while also gaining the flexibility to launch from almost any location the carrier aircraft can reach, or free of the weather delays and fixed launch windows that ground-based rocket pads have to work around constantly. Smaller companies had experimented with air launch for years using conventional, repurposed aircraft. Alan's ambition was to build something purpose-made for the job from the very beginning, on a scale nobody else had seriously attempted before him. The wing itself became the aircraft's defining feature. Stretching 385 feet from tip to tip, it finally surpassed the wingspan record the Spruce Goose had held for more than 70 years. A record many aviation engineers had quietly assumed would never be broken at all, given how unlikely it seemed that anyone would ever again need an aircraft built quite this large. Stratolaunch named the finished aircraft Roc, after a mythical giant bird from Arabian folklore said to be large enough to carry elephants in its talons. A fitting name for a machine whose entire silhouette seemed to belong more to legend than to any conventional aviation blueprint. Fully loaded, Roc can carry up to 500,000 pounds of payload beneath its central wing section, suspended between the two fuselages in a position no other operational aircraft in the world is built to accommodate. Paul Allen died in October 2018 after a long battle with cancer, roughly 6 months before Roc would finally complete its first flight. He never saw the aircraft he had personally funded and championed for so many years actually leave the ground. A small, quiet tragedy tucked inside an otherwise triumphant engineering story. Roc finally flew for the first time on April the 13th, 2019, so taking off from the Mojave Air and Spaceport in California, where it remains based today. Its enormous twin fuselages and single connecting wing making it instantly recognizable from any angle, on the ground or in the air, unlike absolutely anything else flying anywhere in the world at the time. In the months following that first flight, the company Allen had built faced a far less glamorous challenge than wingspan records or rocket physics, simply staying financially viable without the founder, whose personal fortune had quietly absorbed the project's mounting losses for nearly a decade beforehand. Without Allen's continued backing, and without a single rocket ever actually launched from beneath its enormous wing, Stratolaunch's original orbital ambitions began to look considerably less certain than the aircraft itself had ever been, leaving the company's small remaining leadership team facing a question Allen himself had never needed to answer while he was still alive. What exactly an aircraft this specialized and this expensive was actually for, if the orbital mission it was originally built around never quite materialized the way everyone had hoped? That uncertainty did not last especially long, though the resolution looked nothing like what Allen himself had originally envisioned for the company. In 2019, the investment firm Cerberus Capital Management acquired Stratolaunch outright, and rather than continuing to chase orbital rocket launches that had never quite materialized into an actual paying customer, the new owners redirected the entire company toward a completely different and considerably more urgent mission: testing hypersonic vehicles on behalf of the United States military. That pivot turned out to suit Roc's unusual design almost perfectly, repurposing an airframe built for one specific mission into a platform genuinely useful for an entirely different one. Instead of carrying a rocket destined for orbit, the aircraft now carries a much smaller, uncrewed test vehicle called Talon A, releasing it over the Pacific Ocean at high altitude so it can accelerate independently, to speeds classified as hypersonic, generally defined as anything beyond 5 times the speed of sound. The first Talon A vehicle flew in March 2024, an expendable test article that reached high supersonic speeds just short of that hypersonic threshold, gathering data that engineers used to refine a second, reusable version of the vehicle. That reusable version, to designated Talon A2, achieved something no American aircraft had managed in more than half a century. In December 2024, and again in March 2025, Talon A2 launched from Roc, exceeded Mach 5 over the Pacific, and then landed intact at Vandenberg Space Force Base in California, proving the vehicle could be recovered and reused rather than simply destroyed or lost after a single flight. Stratolaunch's chief executive, Zachary Crevor, described both flights as meeting the Department of Defense's performance benchmarks within a margin of just 1%, an unusually tight tolerance for a technology this new and this difficult to test safely. The Pentagon confirmed that these tests marked the nation's first return to reusable hypersonic flight testing since the X-15 rocket plane program ended in 1968, a gap of more than 50 years during which the United States had tested hypersonic vehicles only as expendable, one-flight-only articles that could never be examined or reused afterward. The significance of that achievement goes well beyond setting a new speed record. Hypersonic weapons and defense systems have become an area of intense competition between major world powers, and testing them safely and repeatedly, rather than losing an expensive prototype on every single flight, matters enormously to how quickly any country can actually develop reliable hypersonic technology. Each recovered Talon A vehicle can be inspected afterward, its sensors and structure examined in detail, and then refurbished for another flight, turning what used to be a single, irreplaceable data point into the start of an ongoing, repeatable testing program. This Talon A is powered by an engine called Hadley, built by a company named Ursa Major, and the entire program operates under a Pentagon initiative called the Multi-Service Advanced Capability Hypersonics Test Bed, designed specifically to let the military test hypersonic components faster and more affordably than traditional custom-built test programs ever allowed. Roc itself flies these missions as a kind of mobile launch pad, taking off from Mojave, climbing to a predetermined altitude over the Pacific Ocean, and releasing Talon A from beneath its central wing at a precise moment calculated well in advance of the flight. Pilots who fly Roc on these missions describe the handling as surprisingly stable for an aircraft with 2 separate fuselages. Though takeoff and landing both require considerably more runway than a conventional cargo jet of similar weight. Between missions, the carrier aircraft undergoes the same kind of careful inspection any large aircraft requires. Though one built specifically around an airframe, unlike anything else any maintenance crew anywhere in the world has ever had to service before. By 2025, the company had already booked a full flight schedule of similar missions, and begun taking reservations for tests stretching well into the following year. Evidence that whatever uncertainty followed Alan's death had by then mostly resolved itself into a steady, genuinely useful flying schedule. Roc itself, the aircraft Paul Allen never lived to see fly, has become something closer to a flying laboratory than the orbital launch platform it was originally designed to be. Its twin fuselages and enormous wing now serving a mission its own founder never specifically imagined, though one that still depends entirely on the same basic engineering trick, carrying something smaller and faster up to where the sky thins out and letting it go. While American engineers were chasing speeds nobody in their own country had touched in more than half a century, an aircraft built decades earlier on the other side of the world, sitting quietly outside Kyiv, had already lived an entire lifetime of records of its own. Before that lifetime came to an end far sooner than anyone who helped build it had ever expected. That aircraft story begins with the same Soviet space program that built the Buran. It's a reusable spacecraft designed as the Soviet Union's answer to the American space shuttle program, then capturing headlines on the other side of the world. The Americans had solved a similar transport problem years earlier, using a modified Boeing 747 to carry their own shuttle orbiter piggyback between landing sites and the launch pad. But Buran's launch architecture was different enough, and the associated Energia rocket boosters large enough, that no existing Soviet aircraft came anywhere close to handling the job. Moving Buran and the massive rocket boosters meant to launch it from their respective factories to the launch site required an aircraft considerably larger than even the An-124 we spent 2 chapters with earlier tonight. So Antonov's engineers simply began stretching that existing successful design into something bigger still, treating the An-124 less as a finished product and more as a starting point for whatever came next. Rather than starting completely from scratch, the new aircraft borrowed heavily from the An-124's wings, tail, and basic systems, lengthening the fuselage substantially and adding 2 additional engines, bringing the total to 6 instead of 4. Engineers also moved the tail configuration to a distinctive twin-fin arrangement, partly to keep the structure clear of the enormous cargo that would eventually ride on top of the fuselage rather than inside it, since Buran itself, along with its associated rocket boosters, was simply too large and too oddly shaped to fit inside any cargo hold at all, no matter how big that hold happened to be. While carrying something externally meant reinforcing the entire spine of the fuselage to handle loads pressing down from above, rather than weight distributed evenly inside a sealed hold, an entirely different structural problem than anything Antonov's engineers had previously solved on the An-124, requiring entirely new structural calculations for stress points that simply did not exist on any aircraft designed to carry its cargo on the inside. Viktor Tolmachov, who had served as chief engineer on the An-124, took on the same demanding role for this new, even larger design, carrying forward hard-won lessons from one program directly into the next. NATO assigned the new aircraft, officially designated the An-225, the reporting name Cossack, evoking the historical horseman long associated with Ukrainian identity and independence. Though within Antonov itself, and eventually around the entire world, the name that actually stuck was simpler and considerably more personal than any official military designation or NATO code could ever hope to be. The aircraft made its first flight on December 21st, 1988, and the numbers involved were almost difficult to process even by the standards tonight's list had already set. It measured 84 meters from nose to tail, with a wingspan of 88.4 meters, both figures considerably larger than anything that had ever flown before it, including its own immediate predecessor. Maximum takeoff weight reached an extraordinary 640 tons, and payload capacity climbed to 250 tons, roughly equivalent to the combined weight of 52 adult elephants standing together on a single cargo deck. A comparison Antonov's own engineers reportedly enjoyed using when describing the aircraft to visiting journalists who struggled to picture the number any other way. Only one example of this aircraft was ever fully completed. A second airframe, built to a slightly different configuration, was started during the final years of the Soviet Union, but never finished, its construction abandoned as the country that had ordered it stopped existing before the work could be completed, left as an incomplete shell of a sister aircraft that would sit unfinished in storage for decades afterward. A half-built giant waiting for a purpose that, for a long time, nobody could quite justify funding. The single finished aircraft received a name that, in hindsight, would carry far more emotional weight than anyone involved in its construction could possibly have anticipated at the time. In Ukrainian, the word chosen was Mriya. It simply means dream. The aircraft flew several missions ferrying Boeing components and rocket sections during the late Soviet space program, exactly the role it had been built for, before that program itself began winding down as the Soviet Union's resources and political will for ambitious space projects started running out at roughly the same time the country itself began to fall apart. By the early 1990s, with the country that built it no longer existing, and the space program it served largely abandoned, the aircraft that had been designed to do one extraordinary job found itself with no remaining job to do at all, mothballed in a hangar outside Kiev, while engineers and the wider world tried to figure out what, if anything, came next for something this singular, this expensive, and this specifically built for a mission that simply no longer existed. That uncertain stretch in storage did not last forever, though resolving it took the better part of a decade and required Antonov to rethink entirely what kind of aircraft Mriya actually needed to become next, now that the mission it had originally been built for no longer existed in any form. The answer arrived gradually, toward the end of that decade, when Antonov refurbished the aircraft and reintroduced it to active service under a new identity entirely. No longer a space program support vehicle, but a commercial heavy-lift freighter available for charter, but operating under the company's own airline division, Antonov Airlines. Refurbishment meant considerably more than simply repainting the aircraft and finding it new work to do. Engineers had to recertify systems that had sat dormant for years, replace components that had quietly aged out of service even while the aircraft itself never flew, and essentially relearn how to maintain a machine that, by the time it returned to active duty, had no living equivalent anywhere else in the world to compare notes with or borrow spare parts from in an emergency. In its second career, Mriya quietly became one of the single most recognizable aircraft on the entire planet, despite there only ever having been one of it in existence. It carried generators, including a large unit purchased by a Western Australian resources company that touched down to considerable local fanfare at Perth Airport in May 2016, an event significant enough that an entire community turned out simply to watch one single aircraft land and taxi to its parking spot. It carried wind turbine blades too long to ship any other way, disaster relief supplies following earthquakes and other emergencies around the world, and oversized industrial equipment that smaller charter aircraft, including its own predecessor, the An-124 simply could not accommodate, no matter how carefully, the cargo was packed or arranged. Over the years, it set numerous world records for the heaviest single piece of cargo and the heaviest total payload ever carried by a production aircraft. Records that, by their very specific nature, and all could only ever be broken by another aircraft exactly like it. And there was only ever one aircraft exactly like it anywhere in the world. Aviation photographers and enthusiasts tracked its rare public appearances the way other people might track a celebrity, since simply knowing which airport it might land at next was for a certain kind of person genuinely exciting news. In February 2022, the aircraft was sitting at its home base, Hostomel Airfield near Kyiv, undergoing routine maintenance. It had completed its very last flight just 3 weeks earlier, on February 5th. Within only a matter of days, fighting reached the airfield as the early stages of the Russian invasion of Ukraine unfolded around it. And on February 27th, 2022, the aircraft was destroyed on the ground, caught in the middle of a conflict that had nothing to do with cargo and charter flights or aviation history at all. Antonov's response, posted publicly within hours of the loss, was simple and direct in a way that resonated far beyond the aviation community alone. "The dream will never die," the company wrote, a quiet but deliberate echo of what the aircraft's own name had always meant since the day it first received it. Ukraine's foreign minister offered a similar sentiment, writing that the dream the aircraft represented, in the broadest sense, could not be destroyed along with the airframe itself. Messages of support arrived from aviation enthusiasts and engineers around the world, many of whom had never seen the aircraft in person, but had nonetheless grown up watching footage of it, land at airports on every continent over the years, so one of the very few aircraft genuinely famous enough to draw a crowd simply by showing up unannounced. Antonov has since confirmed that rebuilding the aircraft remains an active goal, though a difficult and expensive one. Estimates for the cost of reconstruction range from roughly $500 million on the lower end to more than $3 billion on the higher end, with a construction timeline measured in years rather than months, and the unfinished second airframe from the original Soviet program, the one abandoned decades earlier when the project briefly seemed to have no future at all, has been mentioned as a possible starting point for whatever comes next. A strange kind of symmetry. One unfinished giant potentially becoming the foundation for replacing another. Nothing about that future is certain yet, and engineers familiar with the project have been careful not to promise a specific date or even a guaranteed outcome. What is certain is that an aircraft named after a dream has already proven once that dreams this large can be built at all, and that may end up mattering more than whether this particular one ever takes to the sky again. That word, dream, is as good a place as any to pause and look back across everything tonight's hangar has held. 10 aircraft, from the smallest to the largest, and somewhere along the way, the word largest stopped meaning just one thing. The Beluga XL we met first tonight was, by almost every visible measure, the smallest aircraft on this entire list, and yet it carried more usable cargo volume inside its strange, bulging hull than aircraft twice its outward size. The Dreamlifter looked larger still and lost that particular contest entirely. Size, it turns out, was never really one number. It was wingspan, length, weight, and volume, 4 separate kinds of enormous, distributed unevenly across 10 very different machines, built for 10 very different reasons. Some of these aircraft existed to solve a logistics problem nobody outside the aviation industry ever thinks about. How do you move an airplane wing, or a satellite, or a section of another airplane when nothing else built can carry it? Others existed because 2 superpowers spent decades convinced that whoever could lift the most weight, the farthest distance, fastest, held some kind of advantage worth pursuing at almost any cost. One existed because a single, stubborn man wanted to prove a wooden aircraft could fly, even after the entire reason for building it had already disappeared. One existed because a software billionaire believed rockets deserved a better way to reach space, and ended up building something that found its real purpose only after he was no longer alive to see it. And one, the largest of them all, existed to carry a spacecraft that would only ever fly a handful of missions before its own program quietly ended, outliving that original purpose by decades, carrying generators and turbine blades and disaster relief supplies to ordinary people who had no idea they were watching the largest aircraft ever built land at their local airport, right up until the week it didn't survive a war that had nothing to do with any of that. What connects all 10 of them, underneath the wingspans and the tonnage and the engine counts, is something considerably simpler than engineering. Each one took years, sometimes decades, of people who would never see the project finished, agreeing to keep working on it anyway. Each one demanded a kind of patience that has very little to do with speed or ambition in the usual sense. The patience of building something at the absolute edge of what physics allows, trusting that it will work before anyone can actually prove that it does. That patience is the real thread running through tonight's list, far more than any single number ever could be. Behind almost every aircraft on this list sits a person whose name rarely gets mentioned outside of aviation history books. Oleg Antonov, who personally guided the An-22 and the An-124 before his death, never lived to see the An-225 his own design bureau eventually built from those same foundations. Women working in a plywood mill in Wisconsin, far from any battlefield, spent their war laminating birch veneer for an aircraft most of them would never see fly even once. Paul Allen funded an aircraft for nearly a decade and died 6 months before it finally left the ground. None of these people set out specifically to appear in a list like this one. They simply kept building, year after year, towards something none of them were entirely certain would actually work. There is also a quieter pattern worth noticing: the way these 10 machines split almost evenly between 2 very different reasons for existing. Some, like the C-5 Galaxy and the An-22 and the An-124, were built because 2 rival superpowers spent the better part of a century convinced that whoever could move the most weight, the farthest distance, held some kind of decisive advantage. Others, the Beluga XL, the Dreamlifter, the An-225 in its second career, existed simply to solve an ordinary, unglamorous logistics problem, moving one specific oversized object from one specific place to another. The largest machines humans have ever built turn out to be motivated by surprisingly small, practical questions, almost as often as they are by grand ambition. If you found tonight's hangar a comfortable place to rest for a while, you are welcome back any time. Some nights here, it's the largest machines humans have ever built. Other nights, it's something far smaller and far older. The quiet physics of a beaver dam, the slow, patient engineering of an ocean liner, the size of a small town, or some other corner of science and engineering, built for exactly this kind of stillness. The hangar door will be open again tomorrow night, and whatever waits inside it, large or small, dream or machine, will still be there whenever you're ready to come find it. For now, the lights are dimming, the engines have gone quiet, and there is nowhere else you need to be.